All right, stay. All right, so let's put this formula sheet together. So, whatever you put up here on the board is the only stuff you can have on your formula sheet. I think several of you, unfortunately, learned that lesson the hard way. So don't put notes, don't put example problems, don't put little cryptic, neat shorthand for stuff, right? Here we go. So you could bring in all your old formula sheets as long as you didn't lose any points on them. If you lost points on them, you probably want to rewrite them. And then you can just add these to it. All right, so, I mean, you already have this somewhere. So just make sure you have this sitting somewhere. All right? So we need that. If you want to, I mean, the z-score formula doesn't really change, but officially when we're doing hypotheses tests, you're actually doing this, where this, of course, is the new standard deviation. Is that cool? You guys can write that if you want to. How are we doing so far? Good. All right. Doing fantastic, man. What are you talking about? Got tomorrow off. That's going to be neat. I could deal with some more Wednesdays off. It'd be nice. All right, let's see. I don't want to miss anything. Yeah, so then we've got... Then we move into the bigger z-score. We got the z-star for one sample proportions. Remember this here? Do you guys remember that? Yes? Sort of? Like I've seen that before somewhere. In a nightmare. I don't know if anybody's having math nightmares. Has that happened to you yet?
Yes.
Yes? Okay. Well, imagine all the math I took. I had some really creative math nightmares. All right, let me think. I don't want to miss anybody. Then you got this bad boy here when you take two samples. And I'm going to be nice because, well, actually, let's, it doesn't matter. However you want to put it. So we can put two of these formulas down. I'll just go ahead and put two of these formulas down. So you got that, and you've also got that. Which is the same damn thing except what?
S.
S. I like that. The biggest mistake people make is they forget to square the little standard deviations. And then, of course, if you don't do that, it's going to throw everything off.
Can we write next to it if we don't want to rewrite it, just or S?
Sure, I love it. I wouldn't write it twice, but if you want to write it twice, do it. Because it's the standard deviation. You put the standard deviation you know in there. That's what you use. Okay. I'm going to be nice, again, because I love it when I do this. But just to make this easier, I think in class I told you guys, don't write this down, but I told you guys this here. Right? Don't everybody guys remember? Let's do this, because that's for a different situation. Let's make this easy. This is what we do in general if you don't want to use that big ugly formula. You make the degrees of freedom equal to the smaller of n1 minus 1 or n2 minus 1. So it's just the smaller degree of freedom. You with me? So, what's up? Totally, because I just wrote it. Everything I write on this board can go on your formula sheet. So I am being really nice there. Look at that. You've got the word smaller on. Holy shit. I don't see any other words on there, though. Does it make sense? So if one sample size was 78 and the other one was 32, 78 and 32, what degrees of freedom would you use? 31. I like it. And that goes with the theme of always being more conservative. Do you guys understand? So if I use the smaller sample size, my t-score is going to be bigger, making it a harder test to pass, and that's being more conservative. Let's see, what else we got? Oh yeah, for the two sample population problem. So this is the one that's going to take a little bit of explaining. You guys remember this? Well, this was the pooled percentages. Right? So P hat 1 and P hat 2 is where you segregate everybody. Men, women, older, younger. Right? And PC, I love PC, that's funny. I just realized that. It's PC. PC principle. So that's where you have, don't look at their differences. Put everybody together. So that actually works really well if you understand what PC is. If you watch South Park, even better. Further ahead. So PC is just you take everybody and put them in one big group. So I don't know if this formula is going to make sense, but how do you find P hat in general? How do you find P hat? It's X over N, right? Successes over the total. So if I talk to 800 people and 300 of them say something, it'll be 300 divided by 800. X divided by N. So PC is take all the X's from the first group, add it to the X's from the second group. Just put everybody together. And then take everybody from the first group and add them to everybody in the second group. And so you got one big group, not two separated groups, right? That's not PC.
But then QC is just the...
It's just 1 minus PC. So if it's wearing a hat, or if it's got a little ankle bracelet C, right? It doesn't matter what it's wearing. They are always, one is 1 minus the other. How we do so far?
Can I write that?
Sure, man. QC equals 1 minus PC. Q hat equals 1 minus P hat. Q sock equals 1 minus P sock.
They could be throwing like horseshoes, you know. Like,
oh, I see. Yeah, they got the horseshoe ready. I like it. That's cool. No matter what they're wearing or carrying or playing, right? Q soccer ball equals 1 minus P soccer ball. All right, and somebody in this room is like, soccer ball? What the hell's he talking about? Should I write that? What the hell's going on? Soccer ball. Sorry if that is you. I'm making fun of you. Just want you to make sure you understand. So has anybody else got a formula I might have forgotten that you want to add to this? You should. So again, you can bring in your confidence interval formulas. You can bring in all your old formula sheets. Maybe rewrite the ones that you might have lost points on.
what about for confidence intervals?
So those should be on your last formula sheet, right?
Oh, the last one. Okay.
Right? But again, I mean, you got this guy, this guy. I think we did all of them on the last test, didn't we? You should have all those. You can just rewrite your formula sheet if you don't want to bring all your old formula sheets in, but just keep track of all your formula sheets. Bring them all. And on the day of the final, you just bring all the damn things in. Big old stack of formula sheets. And you know, and you got these guys too here. But you should have those on a previous formula sheet, right? Yes, ma'am.
Is the error-bound formula on the last sheet?
Come at me. What do you mean?
Like to find like the error percentage, like how to switch like P and N. Is that on there?
Oh, so those should be on there, but you can write them again if you want to. Right, these guys should have been on your last formula sheet, if I remember correctly. But you can write them again if you want to. You can leave your friends behind. Just leave friends sometimes. Alright, does anybody else have anything else that might be left off of here? Any other suggestions? Okay, so that's it. So anything else you have on there, you're going to lose points for. Unless you clear it with me before the test, right?
Do we do little boxes, like over, like just to organize it?
Sure, yeah,
Okay.
sure. That's fine. Boxes are good. Yes, ma'am.
What about for if the percentages are normal and P greater than 5 and Q greater
Oh,
than 5?
good. That's a concept. You should know that.
Oh.
I like it. Just like n greater than 3. I don't want to see that written down here. Something you should know. So if you have an NPQ problem, how do you check if it's normal? You look at NP and NQ. You have to know that. Anything else? Okay. So if you're just getting in here, this is the formula sheet board. Everything on here you can write down. And you can bring in your old formula sheets too. Yes, ma'am?
Do you want us to turn in all of our formula sheets if we're doing them all?
Yes. Cool. You just turn in everything, basically everything on your desk top gets turned in. Plenty of paper, yeah. And your calculators and your phones. No, just papers. Okay. All right. So, who had a chance, anybody have a chance to actually look at the practice test? Anybody?
Yeah.
A few of you guys? All right. So it's wide open. We can do homework problems. We can do stuff on the practice test. I've got the answer key that I'm going to keep for a little bit. Just so a few of you that would leave otherwise might stay for a little bit. Answer key. Come on. Yes.
Might I propose we maybe like refresh about last class, like when we did the PC problems? That one
Sure,
was
totally.
easy about. I don't know
All right.
if anybody else
Yeah.
is.
I like it. So normally I like kind of working backwards with the more recent stuff.
Yeah.
Sure.
I had a quick question for the homework. On page 507, number 73, D and E, what is the range variable?
507. 73. What's it? Where's it? Which part?
D and E, the random variable.
Oh, let's see. So, blah, blah, blah. Approximately 9.5% of American adults suffer from depression or depressive illness. Well, suppose in a survey of 100 people in certain towns, 7 of them suffer from depression or depressive illness. So, the random variable for the test for any group of 100, what am I going to collect? Well, how am I going to create P hat? If I talk to 100 people, I'm going to ask them.
Oh, that's true.
Yeah, so remember the variable is pretty much always related to the question you would ask people, because then the data are the answers that you get. So the variable is pretty much the question you would ask people, right? Blah, blah, blah. In words, define the random variable for this test, so then you can define it there. Okay. Is that cool? All right. So let's do example problem. I don't know. You want to do the one that practice test or one from homework?
Practice.
Practice test?
Yeah.
And you said the one that deals with, like number 6.
Yes.
Okay.
That'd be really cool. That was something that was a little bit.
Yeah, I know. Stats is really cool. So that would be really cool. All right.
Yeah.
Is anybody still copying this down? You guys got this? Yes. All right. Oh, look at that. Holy crap. Wow. That is expensive compared to racks. Okay. There you go. How's he doing?
Good.
He's good? He's been acting up. So, looking at number 6, and everybody, a few more people came in, so has everybody got a copy of the practice test? Everybody? Okay, so we're looking at number 6 right now. So no matter what it's all about, any hypothesis test problem, what would it do first? You're freaking me out. What's the very first step in any hypothesis problem? What's going to drive the whole thing?
Claim.
The claim, right? If there's no claim being made, I'll just go to the next problem. Ain't nothing to check. So the claim is what drives me. So it starts everything off, and then I don't worry about it again until the very end, right? kind of makes sense. The conclusion is going to be all about, well, how'd your claim do? Did it work? And that's why our conclusion's got to be written about the claim. So what is the claim on number 6?
The two proportions are the same. That
Yes. So, in general, now this one is not as critical because they're not equal to, so who cares which one's 1 and which one's 2. But when you have 2 samples, you've got to call one of them 1 and you've got to call the other one 2 and keep it consistent. Or else the formulas you might go on the wrong side of your rejection region stuff. You might, right? And this problem is going to be 2 tails, so it almost doesn't matter. But who do you want to call 1? Probably the first thing I see, which are students. So we'll call students, we'll call population 1. And teachers will call population 2. So P1 and P hat 1 will all refer to students. P2, Q hat 2, all that kind of stuff is going to refer to teachers. Cool, I like it. How we doing? Do that first for yourself and for me. So then the claim is P1 equal to P2. I can't remember if I said same or different. All right. So step A, is that going to be the ho or the high?
the hoe.
The ho, because it has an equal sign staring you in the face. So what's H1 going to be? Not equal to. So like we said, this is going to be a, how many tail test?
2 tail.
2 tail. So in this problem, what's the second step? I mean, any hypothesis test, the second step is always, is it normal? Do I use Z or T scores? Right, that's the second step. On this type of problem, how do I check to see if it's normal?
Greater than 30.
5.
Oh.
And do I know P1 and P2? Do I know them? No, I don't. I know P, or I can figure it out. I know P hat 1. Right? So let me see if you guys, are you guys with me? If I don't know P, I got to use P hat. If I don't know sigma, I got to use S. If I don't know mu, I got to use X bar. Always. So I don't know freaking P1s. I got to check NP1 hat. And some of you guys are going to understand what I'm about to say. NP1 hat is staring you in the face. But some of you guys are like, that's nice to know, Jeff. Freaky dumb. So what is P hat 1? So N1, P hat 1, N2, P hat 2. We got to check all that and the Q's. Yay, Jeff. So what's N1?
That's going to be 84.
84. And what's P hat 1? 63 out of 84. Do you see how silly that was for me to do that? 63, I can see it. That's the number of successes in the first group, because that's what 63 means. Some of you guys understand what I just said?
Yeah.
Some of you guys not quite, but you can just put the formula together. And what's true about this? 63 is bigger than 5. So far, so good. So what's N1 Q hat 1? If 63 people were successes, how many were failures? 21. And if you do the work, it'll come out to be 21, and that's bigger than 5. So what's N2 Q, Q. What's N2 P hat 2? How many successes in the second group? 34, which is bigger than 5. N2 Q hat 2 must be the rest of the people in the second group. How many total were there in the second group? 51. 34 successes. Therefore, how many failures? 17. That is bigger than 5. Yes, ma'am.
And for the test, that's fine. Like we don't have to write.
Totally. I mean, I'm telling you what they are, right? So, the more you know, the less you have to do, and you know the answers. You know what they are. I have to tell you. I have to give you these numbers, right? I have to give you these numbers. And they're all bigger than 5, so I'm good to go. Well, and so what does that mean officially? That means it's normal enough, so I'm allowed to use Z-scores. When would I use t-scores?
Never in
Good. It's
problems.
a trick question. Right? I try to get all my trick questions out of my system before the test. So you would never use t-scores on an NPQ problem because we create our own standard deviation. There's never a question about which one do you have. We got the one I'm going to make. So I never use t-scores for NPQ problems. Right? And some of you guys, sometimes you get confused. You're like, they didn't give me sigma or anything. Well, they don't have to because of what I just said. We make it for NPQ. We have the formula for it. We create it. So we always freaking know it. Right? I don't know if you guys understand. Or if you don't quite understand, just remember NPQ problems, Z or nothing. Right, Z or nothing. So again, this step is always the same. What's my hypotheses that I'm looking at? Then what am I allowed to use to investigate them? Right? In this case, we know we can use Z-scores. Check. What's the next step? Good. Set up the rejection region. What's going to be enough evidence? And then the step after that is, how much evidence did we get? Did we get enough? Right? So what do we know about, what's alpha in this problem? 0.02. How many tail tests? 2 tail. And I'm using Z-scores. That's always makes things, make a Z. There you go, Jeff. Z-scores. So can you look it up on your T-score chart? So that makes this so much easier. 2 tail, 0.02.
2.326.
Yeah, exactly. So, and where does that go? Does everybody see that? Everybody get that? 2.326? Is he right? He could be crazy.
No, he's right.
He's right. He still could be crazy, but he's right.
I'm not crazy, my mother had me tested.
All right, Sheldon. I just gave it away. Shit. Where does 2.3? Where's you guys? Do you ever watch Big Bang Theory?
Yes.
Okay. Some of you guys are like, what just happened? He's referencing a show. Where's 2.326 go? Yeah, I gave it away. Damn. It's a 2-tailed test, so I put 2.326 there, and I put
Negative.
because we're the humans, we know that's negative. It's below the mean. Right? So then, how do I say that in words? If Z star is greater than 2.326 or less than, we can do what? Alright, so we've set up what's enough evidence and what we do if we find enough evidence. Let me get away from purple. So now that we set up what's enough evidence, we look at our sample, we see what do we see from the sample. So what do we know about from the sample? We know, how do I get p hat 1 and p hat 2? Yeah, so here's p hat 1, 63 divided by 84, right? And p hat 2 would be 34 divided by 51, right? You guys all see that? Does everybody see that? I'm just getting to percentages for my sample. My samples in this case. So this was, what did I say? 34 over 51. So what's 63 divided by 84? 0.75? And what's 34 divided by 51? So remember, I don't know if you guys remember this, but remember. In general, if you forgot, go out 4 decimal places. But for percentages, you have to go out at least 3, just like standard deviation. Believe it or not, if you go out 3, it won't throw your z-star off. But if you only go out 2, your z-star can move quite a bit from where it's supposed to be. So go out at least 3 places on those. This, of course, is 0.750, so who cares? All right. Cool, maybe. So if in doubt at anything, go out 4 places and you're covered, right? That's the most we go out on anything. That's the percentages.
I think it was recording.
Poor little dude. Yeah, he is.
Okay.
It's all right. Don't take it personally.
Maybe like a red dot.
Oh, no, that means it's not recording.
Oh,
All right, how are we doing there? Yes, ma'am.
For the test, you want us to show every single step.
Yes. You mean like this step and this step? Yes. If you leave any step out, you're going to lose points for that step.
Would you give us like an outline of like this?
Totally. I'm going to give the first hypothesis problem you have. We'll have all the steps. Any hypothesis test after that will say use the same. I think I did that on the practice.
Okay.
Yeah, see number 4, I gave you all the steps. Number 5, I said use all the steps. Right?
Oh, okay.
Cool. I like it. So I'll do the same thing on the actual test. So just do all the steps. Don't skip any. That'll so suck. Because then I have points for each step. If the step's not there, you're going to lose all those points. So N1 is 84, N2 is 51. Is that cool? What's PC? I got it, bro. PC, bro.
So,
X1 plus X2.
Yeah, so you take all the successes, so 97 divided by everybody. So there's 97 successes, right? And how many total people are there? 135 people. So you look at one big group of people. So P hat 1 says, and I forgot the situation already. P hat 1 talks about the percentage of students who want the semester shortened. P hat 2 talks about the percentage of teachers that want the semester shortened. PC says what percentage of people that you talk to. Right? We're all just people. I'm up here, you're there. Who cares? I'm a person, you're a person. Aw, PC. So 97 people out of 135 people feel that it should be shortened. And that's sort of like averaging the percentage out. You're always going to get something in between these two. And what do you get? 719. Yeah, that sounds familiar. 719? Okay. So now you get everything you need to throw it into the big bad formula. It's a big one just because we have two sample stuff. So P hat 1 minus P hat 2 over the square root of PC times QC. What's QC going to be?
1 minus.
Yeah, 0.281. 1 minus this, right?
Is that still step D?
Yeah, dude.
Oh.
Aw. Sorry.
No.
I'm still on step D. Sorry, Renee, I'm not. Yes, I'm making. So 0.281 times 1 over N1 plus 1 over N2. I want to make this, some of you guys, just real quick. For a single proportion, not two samples, but just one sample, it was P hat minus P over the square root of PQ over N, right? Do you see how this, if I distributed this, it would be PCQC over N1, PCQC over N2. It's both in there. I just made room for two standard deviations. It's PQ over this plus PQ over that. There's both. I don't know why I put N's instead of what they actually are. But we'll see why. What was N1? 84. N2, 51. So now it's all about, can you put this into your calculator correctly? Right? And just to put it up here more nicely, I would say that times parenthesis that, close parenthesis, close parenthesis. If you have a newer calculator where the square root gets big, that's nice for you. You know, and I think I'll show you something that will, I don't know, let's see. I actually don't care if you don't understand what. I'm going to show you how to check your work in the calculator, and what some of you won't understand is why I make you do all this, because you're like, calculator, just told me the answer. Right? And I am, again, I'm making fun of you if you feel this way. Because then, as I say, the calculator will pass statistics and go to the next course, and you will stay here and take it again. Right? I think the calculator can pass this course. Right? But I'll show you, because some of you guys, I think, know how to do several things in the calculator, because maybe you took stats before and the teacher did everything on the calculator. Well, they suck really, really bad. right? And I don't care if you're upset at me because I make you do everything by hand. Oh well, you're learning it better. Sorry, I'm working through some stuff. Students, sometimes it drives me crazy. All right, so let me show you. This is kind of nice. Okay, we'll do this problem again. We're not quite done with this problem, by the way, but we'll do it again as soon as that wakes up. So what did you guys get?
1.04.
1.04. I love it. Can somebody help me out? What's the p-value? What's the p-value? So here's 1.04, like right there maybe. So the p-value is the area in that tail. That's all it is. Alpha is the area in the tail of the projection region z-score. The p-value is in the area of the tail of my z-score. Since it's a two-tail test, I'm going to have to double it to make it fair.
So wait, it's 1 minus.
Totally. So you look up 1.04, that's this. That's not the tail, this is the tail, so you got to do 1 minus that. So what do you guys get just for the area in that tail? Was it 1.04? What are you guys getting? Should be related to Christopher Columbus.
1492?
Yes. So that's 0.1492. It should be. So you guys able to see that? Because what do you get when you look up 1.04? You should get 0.8508. Is that what you get when you look up 1.04?
You have to.
And then you do 1 minus that to get the area in the tail. So what's the p-value? That's not the p-value. What's the p-value going to be? What do you do with 0.1492? Since it's the two-tail test, I
Times it by 2?
double it. Yeah. And can you tell me this? If you want to find evidence that the null is wrong, do you want a big p-value or a small p-value? You want a very small p-value. Because the p-value tells you how likely it is that what you just did would happen if this is right. So that is pretty likely. That's, what is that, 0.29 something? 2984? So almost a 30% chance that what we just did would happen if this is right. So that's most likely right. That's not a small, I need it to be, if it was like a 1% chance that it would happen, then that must be wrong. That's why if the p-value is smaller than alpha, if the p-value is small, this must be wrong. Because the chances that it's right are small. So the p-value, to really boil it all the way down, this might be stripping it down almost too much, but the p-value is basically the probability that this looks right. Yes, ma'am?
So the p-value is going to be the one going to the right?
Well, it depends. If my z-star was down here, it would just, it's always in the tail that my z-score makes. And the tail that my z-score makes. So if my z-score is here, is that the tail or is that the tail? That's the tail, right? That's the body. I don't know if you guys, what's up? So, I mean, it's pretty obvious if I make it pretty far out there. This is the tail, right? That's the tail. No, it's not obvious?
Yeah.
I don't know. Even biology, normally the tail is smaller than the animal, right? No? So the tail is just going to be away from the middle. See, this, if I go this way, that includes the middle, right?
Oh.
So it's away from the middle. There you go. I just got to find the right phrase.
So no matter which way you go, you still got to subtract by 1.
Well, if my z-score had been negative, if I look at negative, that would have been the answer, because that would have been below. It's just because it was above, I had to do 1 minus. It's like from when we first learned z-scores. Yeah. All right.
Yeah, so it's like you have the mu, and if it's on the right side, closest to the right tail, then you're going to go that area to the right. If it's on the left side, you're going to find the area to the left tail on a two-tail test.
X bar? Oh, no.
They're like on your on the little picture there. If you know your middle one where your mu is, like if your z-star goes to the left of that, then you're going to look for the left tail, and if it goes to the right,
Oh,
you're
sure.
looking inside it.
Okay, sure. Okay, I'm with you. Just away from the middle. I think that's a nice, quick way to say it. All right, that's enough. If this would have been a one-tailed test, then that would have been my p-value. I just doubled it because it's a two-tailed test. That's all. So what's my conclusion then? What can we say right here? Did we make it far enough away? No. Is the p-value less than alpha? Hell no. So both of those always have to agree. What happened then? We can say we failed. We failed to reject the hoe. We failed to support the high. And which one was my claim?
This is going to be the first one. Failed to reject hoe.
Yeah, the hoe was my claim, so I want to use this language. I've written it down on the answer for somewhere. So we have not found sufficient evidence to reject the claim that the percentage of students and the percentage of teachers are the same. Yes?
So do you go off of the Z-star or the
Bless
p-value?
you. Say again?
Do you go off of the Z-star
Yes.
or the p-value?
Yes.
So
You love that answer. So is my Z-star far enough away? No. Is my p-value less than alpha? No. So they both say that you failed.
what if one does and the other doesn't?
It's impossible for that to happen.
Okay.
I really want you to understand. The closer this gets to 2.326, the smaller the p-value gets. Do you see that? The smaller its tail gets. Until it's right on top, and then they're equal. And then if it's inside, the p-value is less than alpha. So they have to say the same thing. There are two ways of looking at the same thing. That's why when I first taught stats, and I didn't understand what other departments needed, what other fields needed, I'm like, why do you even do the p-value? I can get the answer to it just using a z-score, right? Because they do tell you the same thing, but the p-value is actually more important in everything, in the real world.
Is it because it's easier to interpret? Because it's percentage?
No, it's because it leaves it up to the reader to have their own alpha, have their own level. So if I tell you that a p-value of something was 0.02, some people are like, oh, it's good. My own personal alpha is 0.05. And somebody else is like, no, it had to be 0.01 to convince me. That didn't see. So people can make up their own minds about what the research found or didn't find. Does that make sense? All right. Cool. That's why it's a little weird when I showed you that one and they actually said what they used as being significant. They normally wouldn't say that. They just report the p-values out and let people make up their own minds. Now they might say it looks to us like this happens and this makes this happen. But they don't say what they use as significant because that's up for everybody else to determine. All right, maybe.
So if it was a one-tail test, then the value would say one.
Would have been this. Exactly. It's just, if it's two-tail, I got to double it. Because, is this alpha? No, twice that is alpha. So whatever I get here, I double it to make it fair. Make it go on both sides to make it fair. Right. I could also cut alpha in half to make it fair, but they decided to double this to make it fair. You could have gone either way. Perhaps. Yes?
I understand what you did, but like just on the worksheet it says like for D, summarize the sample information. Like, what do you mean? Like,
Yeah.
what does that mean?
Right there.
Oh, okay.
Yeah, that's all. I'm just trying to help you say, collect all your sample information so you can put what you need together for this. That's all I mean. Yeah. All right. Coolness. Okay. And what else do you want to do? To me, if you understand this, then like number 4 should be easy. Right? It's got a smaller Z-star formula. There's less going on. Yes?
For number 4 and E, you put how would it be different?
Oh, yeah.
Do we have to do the whole problem?
No. So,
Or just like
and I don't know how many noticed that number 5, I wanted it to be the same as number 4, but but it doesn't matter. The 10.4 number, I should have made it 13%, but on the answer key, I just calculated it with what was given. So, on number 4, let me give you this situation, because number 4, it turns out that it doesn't matter. But let's say, somebody help me out real quick. Let's just go right to the heart of it. So I won't have to do the whole thing over again, no. If I had a one-tailed test, z-scores, and alpha is 0.05, what would the z-score be for that? Can somebody help me out? Z-score, one-tailed test, alpha is 0.05. Can you look that up for me? What would the rejection region? start at. Yeah. All right, you guys with me so far?
Yeah.
So we're not doing a whole hypothesis test. Just look at it. So that's part 3, right? Step C, set of the rejection region. So what if my Z star was 1.8? In this case, what would happen? I would be able to do what? Did we go far enough away?
No,
How far did we have to make it?
less than 1.4.
Well, we didn't make
Oh,
it
yeah.
far.
Where's the rejection region? There it is. Did I make it into the rejection region? Yes, I did. Right? All right. So I just don't want to make a whole hypothesis to answer this question because you don't have to redo it. You've already done this work for 0.05. You with me? So I find a Z star of 1.8. Z star is 1.8. This came from alpha. So if Z star is greater than 1.645, we can reject the null. Right? You guys are with me now. You guys are not with me. I don't know why. So if I give you this, that's the rejection region, right?
Mm-hmm.
That's what you get when you look up 0.05. You get 1.6. That's the rejection region, right? So if Z star is more than this, I can reject the null. Was Z star more than that?
Yeah.
Okay, so we can reject the null, support the high, and then I would look to see which one's the claim and blah 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 blah. So now what if I said? Let me keep going. If what if alpha was 0.01? What would change?
The Z value.
Yes, so what would it be now?
2.8.
Careful now, it's a one tail test. Yeah, 2.326, I don't think that's true. So that it would be 2.32. Where would 1.8 fall?
Behind.
Oh shit, I didn't make it. See, so I'm just the point I was trying to make, and I think at some point I changed the number so it didn't work quite the way I wanted it to, is I wanted this to happen. Like one way you do it, you reject it. Yay, because your alpha was easier, it was less significant. Your alpha is bigger, so it's easier to pass that test. If I made the test harder to pass, you didn't pass it this time. You guys kind of... So that's the point I was trying to make. And I think with the numbers, the way they came out, it didn't change. Because I think the Z star was 3 point something or other. And it's like either way you did it, you reject it. Like, argh. But that's the point I was trying to make. That's why articles just leave alpha up to everybody. They just say, here's the p-value. You decide what your alpha is. We're not going to make that decision for you. Yes?
So it doesn't matter if the claim falls in the null or the high. You still would put like if your Z star falls in the rejection region, you would just put reject ho
And support high.
all
Either
the
one.
time. It doesn't matter
Totally.
if the claim is in the
That's the
null.
claim. It does not matter what the claim
Okay.
is.
And it doesn't matter if it falls in the rejection region or not, you're still gonna say that? Like you always
No,
say
the
that?
reason I said this is because it fell into the rejection
So
region.
if it did.
What do I say down here?
Fail to reject
Fail.
ho.
Why did I fail? Because I didn't make it into the
Okay.
appropriately named rejection region.
And
So
then
you
based
fail.
But then based on your claim, you would write your conclusion.
Yeah, exactly. The only point I wanted to make here was that's what that kind of question would mean. This, if it's this, you succeed. If I made it harder, you might fail, right? So if somebody would say, "Oh yeah, they found evidence," and then somebody else is like, "No, they didn't." Both of them are right because it's their own personal way of looking at it. All right. Yes. Somebody.
Oh, I understand.
Yes.
So basically when they say, like, how would it be different if you use this, you just find the rejection region for that
You
one?
you just find the new Z-score for where the rejection region starts. You don't have to redo the whole hypothesis test. That was the Z-score, and now that's the new one.
Right, and then you see if Z-star falls.
And you see if Z-star still does the same thing. On the practice test, it did the same thing no matter what. But the point I wanted to make was, you don't have to redo the whole thing, just look at that one thing will change. What is enough evidence? That's the only piece that changes. Yeah. I like it. But see, now, the p-value, what's the p-value on this problem? What's my z-score? What z-score did we find? What's my z-score? 1.8. So what's in the tail of that?
Maybe the 1.8 is 0.0359.
So you did the shortcut, I love it. And the rest of us, if you look at 1.8, That's this. I need the area of the tail 1 minus. Yeah. Does that p-value change in this next piece? Why not? Because my z-score is still 1.8. So that's why the p-value is what's reported, because it's just what it is. It's not going to change, right? What changes is what's enough evidence. So to get you guys in class, we give you what enough evidence is, just so you get familiar with how to tell, did you reject it, did you fail to reject it. In the real world, they don't tell you this. You come at it yourself with your own. What's enough evidence? That's not enough evidence. Screw you. I need 0.01. That's not enough evidence. You haven't proven anything. Right? And this other guy's like, dude, relax, man. You're pretty good. Do you guys understand? So if you think about it, it only makes sense. In some cases, like I said, if you want to prove to the insurance company you have to pay less money to them, they're going to probably make it hard to pass the test, right? Whereas if I'm in a nuclear power plant again, as we have been several times this semester, I'm probably going to make it really easy to pass the test. So I'm like, the needle starts to go through I'm going to get off my ass. I'm going to go see, is everything all right? Something blocking a filter in here or something? Is the water going? Little three-eyed fish got stuck in? I don't know. No, it's too old. Too old a reference. Okay. Early days of the Simpsons. Yes. Stretching. Okay, that was it. That was advanced yoga. I like that. Stretching. All right. What'd you name on number 3? I like number 3. That should tell you to be ready. That pretty much answered my question. So number 3, it's not ugly. What did I say back in the first test? I said that's the last time I'm going to make you make a table to find the standard deviation, right? So what do you need for the group that passed the class? You need their mean, the X bar, and you need their standard deviation. So how do you find that? Put it into list 1, do 1 bar stats, and it spits it out at you, right? So now that I made you go through the whole thing to see what goes into creating a standard deviation, I'm not going to make you do it again. Because now we got other stuff to worry about, right? So you can just get that right out of the calculator. So if you don't remember how to get that, you probably want to beef up on that. Because I'm going to give you a problem just like that. Yeah.
For that one, it says that it's a population, so you would use sigma, right?
No. It's known that the populations that these samples come from are normally distributed. That's why it doesn't matter. Why did I have to say that? Because the sample sizes are so small, and I don't know sigma. So those two things together, I told you it's normal, so it doesn't matter that n. Let me do the other. It doesn't matter that n is not big enough, right? And then we don't know sigma, so we use t-scores, right? You guys understand that? So that's why I had to say that the populations were normally distributed, because it doesn't matter that the samples are so small. They come from something that's already normal, so they're automatically inherent that they're normal. Yes?
So the only way we would use z-scores for this kind of problem is if you say the population standard deviation.
And see, like I said, which one was it? I thought it was on here. Oh yeah, number 1. It is known that the population standard deviation, I've got to make it really in your face that you have a population standard deviation. So number 1, you should have used z-scores. Yeah. Coolness. All right, let me go ahead and give you guys the answer key so you guys have a chance to look through it. Oh, I forgot. I was going to show you guys.
Hopefully, no.
on this paper, right? There's nothing on the first paper.
Yeah, exactly. No.
Good?
Oh, yeah.
Okay?
I will.
Nice. Not bad.
I'm doing all of it. There's a one, and I have one hour for this.
We're good?
Then I'm gonna come.
So I want to follow through on my comments. I'm going to show you guys how to check this in the calculator. And this is like another level of understanding how something works. So if you don't want to check it in your calculator, you don't have to. It's just I'm making it an option, right? I guess this will help. Turn on. So I think that the newer calculators might have a slightly different setup than what you're about to see up here. Well, let's see what happens. So here's the neat thing. If you go into, remember distributions here? There's all kinds of neat stuff in there. I think on the calculator Bible will actually tell you how to use some of this stuff. Like down here, this is where we went to do like binomial PDF and stuff like that. So it's not in there. As I do that, I'm like, oh yeah, it's not there. If you go to stat, look at the last option. So hit stat button. So you're here. Look at the last option, tests. And can somebody tell me, looking at the cryptic way they describe things, which one of those, it's actually up there on the screen, which one would I use for this test we just did? For the p-hat one, this here. Two, no?
No, a 2 proportional.
2 proportion.
Oh, yeah. What's that?
2 proportion z-test. And is there a 2 proportion t-test option?
Yes. No.
No, good, because there would be, right? You don't use t-scores with NPQ problems. Sorry, made that point in fact. So if you do option 6, a 2 proportion z-test. Let me see. Tell me if it doesn't come up like this, because I don't think I've seen the newer calculators, what they look like. Who's got a newer calculator? Does it look like that?
Right here.
Kick-ass. All right. Sweet. Good. You can just see that better. All right. So now, and again, don't on the test tell me, well, I pushed this button and it did this, and no. It's not showing your work, right? So I just got to fill in what's x1.
That was 63.
63. And 1 was 84, right?
84.
X2?
34.
34.
And 51.
51. And what were we trying to test here? T1, well, I erased it, but what was it for this? This was not equal to, right? Equal to. But what this is saying is what's that related to? HO or H1?
H1.
Good. So this is always going to be what your H1 would be, because that's what you actually test. Is there enough evidence to show it's not equal? So our HO was not equal to, was equal to, so our H1 would have been not equal to, right? HO was equal to, H1 would be not equal to, so that's what I want to use. I don't want it to draw it. That's nice it offers me to draw it. Let me just calculate it. Let's